At first glance, sandpaper doesn't look like much. Just a rough sheet, coated with tiny grains, used to smooth wood or metal. But this tool, the go-to item in every toolbox and workshop, is the result of a process that's technical, deliberate, and scientific than most people realize. You might think sandpaper is just sand glued to paper, but that's not exactly true. In fact, modern sandpaper rarely contains any actual sand at all. It's a high-performance product made using industrial minerals, heat-resistant resins, and precision engineering. So how is sandpaper made? Let's break it down. The story of sandpaper begins with something you don't see, the backing. This is the foundation on which the abrasive grains are laid. It might look like simple paper, but not all sandpaper is made of paper. Depending on the intended use, the backing can be made of paper, cloth, polyester film, or a combination of these materials. Each type has its purpose. Paper backing is flexible and ideal for hand sanding. Cloth backings are stronger, used for belts or machine sanding. Film backings are ultra-smooth and tear-resistant, perfect for automotive or high-precision finishes. Regardless of type, the backing must be smooth, durable, and capable of holding abrasive materials under intense friction and pressure. Once the backing is chosen and cut into large rolls, it goes through a preparation process. It's cleaned, flattened, and sometimes treated with a resin or sizing coat that helps it grip the abrasive grains later. Think of it as priming a wall before painting. It ensures everything that comes next adheres perfectly. Now comes the part that gives sandpaper its bite, the abrasive grains. These are the tiny hard particles that do the actual cutting, grinding, and smoothing. And no, it's not beach sand. Today's sandpaper is made from high-tech materials like aluminum oxide, silicon carbide, zirconia alumina, or ceramic alumina. These grains are synthetic, grown in industrial furnaces at thousands of degrees. Why? Because they're stronger, sharper, and more consistent than natural sand could ever be. Each type of abrasive has a different purpose. Aluminum oxide is the most common, strong, long-lasting, and good for wood and metal. Silicon carbide is sharper and better for sanding harder surfaces like stone or glass. Ceramic abrasives are even more aggressive, used in industrial settings to grind through metal or hardened coatings. These abrasive particles come in a range of sizes, from coarse, visible grains like 40 or 60 grit, all the way down to ultra-fine grits like 1000 or higher, used for polishing and finishing. The size of the grain determines how aggressive the sandpaper is. Coarse grits strip material fast, while fine grits are used to create a smooth, polished finish. Once the abrasive is chosen, it's time to apply it to the backing. This is done using a process called electrostatic coating, and this is where sandpaper becomes more than just rough paper. The backing sheet is coated with a sticky resin glue, then passed under a machine that uses electrical charges to make the abrasive grains stand up vertically as they land on the surface. This method ensures that each grain is pointing upward, sharp side out, like thousands of tiny knives ready to slice into wood or metal. This vertical alignment makes sandpaper cut more efficiently and last longer than if the grains were just scattered randomly. After the abrasive is applied, the sheet goes through a drying oven to lock the grains into the glue. Then comes the second layer of resin, called the size coat. This additional layer acts like a sealant, covering the base of the grains and anchoring them more securely into place. It also protects the grains during use, so they don't fly off the paper under pressure. The sheet is baked again, this time at a higher temperature, to fully cure the adhesive and harden the surface. In some cases, special additives are included in the resin to reduce heat buildup, resist loading, which is when dust clogs the surface, or improve flexibility. Some premium sandpapers even include a stearate coating, a white powdery layer that prevents gumming when sanding sticky materials like paint or resin. Once cured, the sheets are tested for grit consistency, adhesion strength, and flexibility. Machines scan the surface using microscopes and sensors to ensure the grains are evenly distributed and the backing meets durability standards. If any defect is found, uneven grit, missing adhesive, weak bonds, the batch is discarded or recycled. Finally, the sandpaper is cut into its final form: rolls, discs, sheets, belts, or specialty shapes like triangle pads for corner sanders. The rolls are trimmed and wound. The sheets are sliced and packaged. For belt sanders, the ends are spliced and reinforced. For disc sanders, holes might be punched for dust collection. Then it's boxed, labeled with its grit, type, and recommended use, and shipped off to factories, workshops, hardware stores, or your local tool shed. And there you have it, the long, surprisingly technical journey of how sandpaper is made. From industrial minerals grown in fire, to electric fields that make grain stand on end, to layers of resin that bake into a hardened surface. Sandpaper is a finely tuned tool engineered to shape, polish, and perfect everything it touches. From wooden furniture to metal machines, from drywall joints to delicate car finishes. Thank you for watching. Please like and subscribe for more benefiting videos.